Today's lesson in section 2.2, we're talking about graphs of functions. So here we're going to graph several different functions and help you determine what is a function and in like looking at a graph and looking at an equation. Okay, so first start with graphing. So just graphing some general ones. So if you have h of x, which is equal to square root of x, remember you always want, like for square roots, I usually like to do the perfect squares. It just makes it easier to find values and plot the points, so you're not picking, like you're not plotting decimals, but you can, because you have calculators. But I like to start with the perfect squares. Now I want to start with the smallest one. Now most of you will say 1 is the smallest one, which it's one of the perfect squares, because square root of 1 is 1. But the smallest value you can plug in is 0. The square root of 0 is 0. Okay? And then you want to go with maybe 4. That gives you 2. Okay? Now for all these graphs, it depends on what you're graphing. So you don't need 1,000,000 points to graph these points. Okay, now also with your radical, remember there's nothing in this area. Okay, there's nothing that comes to the left of that dot, so don't make a line that way. Okay, sometimes I kind of am picky about that because I want to make sure you understand that radicals, because of how they're defined or their domain that we talked about in the last video or last section, they don't go any further, so they need to be graphed as that or that way. Okay. This next one is an absolute value function. Okay. Now this one kind of looks like a two different ways of describing it. Kind of like a parabola, where it's a U shape. It's more of a V shape. Or let's say you have a line, straight line, and then half of it, like a line you cut through half of it, and then you like reflected one of the halves over the x-axis. That would be another way of describing it. But here, if I have x plus 1, now this one may want your table for it so you can kind of get a grip of what it is. Here, you can just start wherever. There's no like smallest x value to plug in, but there is a smallest y value that you can find. So if I start with 0, it's a good place to start. That gives me 1. Okay. If I go with -1, that gives me 0. If I go with -2, that gives me 1. Or sorry, because I skipped a step there. -2 plus 1 gives me -1, but the absolute value of -1 is 1. Just the same thing as -1 plus 1 is 0, absolute value of 0 is 0. 0 plus 1 is 1, absolute value of 1 is 1. And you could do that in both directions. So you could go like -3, that'll give you the absolute value of 2. 1 gives you the absolute value of 2 as well. So here, you could get this graph. Okay, and so that's kind of what an absolute value function will look like. It's more of a V shape. Okay, and then graphing a piecewise function, I kind of previewed it in the last section to kind of describe where it comes from. But if I'm graphing one, I like to identify where like the turning point is. Now you don't have to do this, but it might help you. So the turning point is at 2. Okay. Now there's different ways of graphing these. You can graph both of them all the way through, and then on a different graph you can like cut them apart and put the parts and the intervals on the graph that you like, and I can show that to you in class. But it may be easier to start with where they are at 2, where x is equal to 2, and then go from there in their certain directions. So because this one says less than or equal to, then we're going to do our graph this function to the left of x plus or x equals 2. Since this one is saying greater than 2, then we're going to graph this function to the right of x equals 2. Okay, but they both meet at 2, so then I want to figure out what they are at 2. So let's say x cubed, when you plug in 2 there, 2 cubed is 8. Okay, so 1, 2, 3. So here, that would be my x cubed one. Okay, and just so we know which one's which, let's use purple for the other one, just so you know the difference. Okay, so for the x cubed one, we're going to use green. So then everything to the left of that, I want to use other values so that I can figure out what x cubed is for my graph. So let's say negative 1, or sorry, 1 would be 1 cubed would be 1, 0 would be 0, negative 1 would be negative 1. You could do the same, keep going. So negative 2 would be negative 8. Okay, so then you could graph your function all the way up to that point and stop. Okay, so over here it would continue going to the left of that function all the way to negative infinity. Okay, now here I want to graph 3x minus 2 to the right of 2. Now I know that it's not including 2, but I do need to show it going all the way up to x equals 2, so that's where we use the open circle. So if I plugged in 2 in for x for 3x minus 2, you would get 6 minus 2, which would give you 4. Okay, so then at 4, you have an open circle, and then 3x minus 2 is a line, right? So then I could use my slope. So 2, 4 is kind of like your y-intercept in this case. So then every point after that, you can use a slope. So 3 over 1 would be my slope. So I go up 1, or sorry, up 3, 1, 2, 3, and over 1. And I could keep doing that, and that would send me up past where my problem is. Okay, so then that would be kind of the look of my piecewise function in this case. Okay? Now, to be able to tell whether something is a function, you can use something called the vertical line test. And a vertical line test is a curve in the coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once. So that means if I draw a vertical line through any of my relations, okay, and I cross it, or cross my relation more than once, then that means it's not a function. If I only can cross my function or relation once, and that's it, at any given spot, then it's a function. Okay, so here I have certain relations. I want to see if they're functions. So letter A, looking at this, it's a circle, okay, or my attempt at a circle. But here you can see I can draw a line through it and hit 2 spots, here and here. Okay, so then that means it's not a function. So we'd say no. Okay, letter B. Now looking at that one looks like it's a function. I can't draw a line at any one spot and get 2 of them. So I would say yes. So that passes the vertical line test. since I didn't cross twice. Looking at letter C, yeah, some places you would be okay, like here and here, but then right there you get 3 crosses, so that would also be a no. Okay. Now another way is sometimes you're given an equation of a relation and you need to determine if it's a function or not. They'll describe this as defining y as a function of x. That just means that the given equation or relation is a function. So if you can define it or make it look like a function, or the equation look like a function, then that means that's a function. Okay, so sometimes, or just to do this, you need to first be able to solve for y, so for your f of x. Some problems are easy, like this one. If I just add x cubed to both sides, okay, then that gives me y equals x cubed plus 8. Now what makes this a function or not a function is if you have any plus or minuses in your, to your variable of x, then that means that it's not a function. What that means is, why it's not a function if it's a plus or minus, is if, let's say I have, y equals just plus or minus x in this case, okay? Then that means I have the function of y equals x, and I also have the function y equals negative x at the same time. So then I could create that vertical line and say it's not a function because it crossed twice. So the plus or minus thing kind of screws up the relation from being a function, so you want to avoid that at all costs. Now for this letter A, you don't have a plus or minus, so then you would say yes, y is a function of x. Okay? Now if you look at letter B, let's see if we can solve this one. So I subtract x to both sides. Okay? And then here I need to square root. Remember, anytime you square root, that means that you need to put in a plus or minus, which is what we said that we didn't want. Okay? So since that's a plus or minus, I can draw this radical above and below the x-axis, making it not pass the vertical line test. So I'd say no, y isn't a function of x. Okay? So that's how you kind of use the vertical line test and figure out if something's a function or not, and be able to graph those. Okay? Have fun.